Hello. Today we're going to talk about using the distributive property, but we're going to be undoing the distributive property. Now, today is going to be very important because it's going to lay the foundation for all of the factoring stuff that's to come. Okay? So the first thing to know is that we are going to have quadratics, meaning a degree of 2, and it's going to look like this: ax squared plus bx plus c. Notice it is in standard form. So your highest degree has to come first, and then your x term, and then your number at the end. So the first step is to identify A, B, and C. Once you know what A, B, and C are, you're going to look for two numbers that multiply to get A times C. But at the same time, they have to add to get B. So you're looking for two numbers that multiply to get A times C, but yet adds to get B. So let's show you what we're kind of looking at. So yesterday, you guys had to come up with a bunch of different number pairs that multiplied to get a certain number. And that was setting you up for today. So let's think about this. We're going to find the number pair that multiplies to get 8, but yet adds to get 6. So you're looking for what multiplies to get 8 but adds to get 6. Well, the multiplies to get 8, it's either going to be 1 and 8 or 2 and 4. But only one of those actually works with the next part, numbers that add to get 6. Now we really don't need to look at the other ones here. We need to ask ourselves, do 1 and 8 add to get 6? And well, the answer for that one is no. So the only one that actually works in both of those cases is going to be 2 and 4. So let's take a look at this. On the right-hand side, this is what we're multiplying to try and get. On the left-hand side, this is what we're going to add to get. So start with the multiply. We want to multiply to get 8. So it's either going to be 1 and 8, or 2 and 4, or -1 and -8, and -2 and -4. Of those, we want to add to get 6. So we are going to find the ones that work, and that would be 2 and 4. So let's try this next one. What multiplies to get 10 but adds to get 7? So multiplies to get 10, adds to get 7. Well, 1 and 10 don't work, but 2 and 5, those work with both of them. So that was going to be 2 and 5. So take a moment and think about the next couple. So this one, what multiplies to get 7 and adds to get -8? Think about it for a moment. So 1 and 7 are pretty much the only thing that multiply, but it doesn't get us -8. However, if they're both negative, then that would work. So it's going to be -1 and -7. So your turn on the next three. Pause the video and think about them for a second, and then unpause and check the answers. The numbers that multiply to get 28 and -11 are going to be -7 and -4. The numbers that multiply to get -24 but add to get -2, they're going to have to be 6 and 4, but the 6 has to be negative in order for it to work. So it should be a -6 and a +4. For the last one, 1 and 12 don't work, nor do 2 and 6, but 3 and 4 would work if it was a -4 and a +3. So the first thing we need to make sure is we have this sense of multiplying to get and adding to get. Because now what we're going to do is we're going to step it out and we're going to take it to the next step. So we're going to apply it to quadratics. So you first want to identify A, B, and C. And so for this one, A is 2, B is going to be -9, and C is 7 because the A is in front of the x squared, then goes the B, then goes the C in standard form. So we are going to be looking for number pairs. that multiply to get A times C, which in this case, if we're doing 2 times 7, we're looking for numbers that multiply to get 14. Okay, so we always do A times C to get the multiply part. The add part is always going to be B, which in this case is -9. So first we identify our own numbers now. So we're looking for what multiplies to get 14 and adds to get -9. So if you need to list out a couple, you can. We have 1 and 14 and 2 and 7. The 1 and 14 is not going to work. The 2 and 7 will work, but they both have to be negative. Add to get -9. So we're going to say -2 and -7. The order does not matter at all. So for our next one, we have to identify A, B, and C. A is in front of our x squared, and when it's missing, it's 1. B is -12, and C is 27. So we are looking for what multiplies to get A times C, which is 1 times 27, or 27. We're looking for what adds to get B, which in this case is -12. So first identify the multiply part, which is 27, and then the add part. So we can use 1 and 27, we can use 3 and 9, and those are our only options. So the only one that would add to get -12 is if we used the 3 and the 9 and they were both negative. And it does work out because -3 times -9 is 27. So our number pair would be -3 and -9. In any order is totally fine. So for this next one, we have A is 1, B is -6, and C is 9. We're looking for what multiplies to get 1 times 9, but adds to get your B value, which is -6. So 1 and 9 don't work. 3 and 3 make 9, and if they're both negative, it would work out with the adding portion. So our numbers for this one are going to be -3 and -3. Okay, so that's the gist of it. I want you to try 4, 5, and 6. So pause the video, identify A, B, and C, figure out your multiply and your add, and then your numbers. Okay, so actually pause it and you try it yourself first and then come back. So let's see how these went for you. For number 4, you're looking for what multiplies to get 36 and adds to get 15. For number 5, you're looking for what multiplies to get 36 again, but adds to get 20 in this case. And for number 6, you're looking for what multiplies to get -4 and adds to get 5. So as a reminder, you're doing A times C for the multiply part and then just B for the add part. So if you've already found your numbers, that is fantastic. Some of these are a little bit more challenging, like 36 has a lot of options. 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So sometimes you have a lot of options to go through. So looking at number 4, the only way we get 15 out of those is if we use 3 and 12, and everything is positive for that one. For the next one, once again, sometimes it helps to list out all of your options because the one that works in this one should have been the 2 and the 18. And the last one is tricky because you have 1 and 4 or 2 and 2, and you might be thinking the 1 and the 4 work, but the problem is if they're both positive to get the 5, it doesn't multiply to get the negative. So nothing works for this one. And that happens sometimes. When you get a number pair where nothing works, it's going to be called prime. Much like if I asked you to break down 5, you'd say, well, nothing goes into it. It's just 1 and 5. So this one is prime because nothing works. And so here's the next important part. So we've done all of this work. We have found our number pairs. What we're going to do is we are going to take our number pairs from above and we're going to split the middle term. So the first thing I'm going to do is just zoom out here and write my numbers again. For number 1, I got -2 and -7. Number 2, I got -3 and -9. -3 and -3 came next. 3 and 12. 2 and 18. And then 6 was prime, so there's absolutely nothing I can do with that one. So you do that process of A times C, find your number pair that multiplies to get that but adds to get B. Once you get those numbers, what we're going to do, and this part is very important for what's coming tomorrow, so please make sure this is going okay for you. You're going to take your first term and rewrite it. So 2x squared. Your middle term, this is called split middle term for a reason. You're going to take that middle term and you're going to split it using the two numbers that we just found. So the -2, I'm going to write -2x, and the -7, I'm going to write -7x. And then the last term, I'm going to bring that down and write +7. So notice, if I were to combine these back together, I would get the exact same equation that I started with. Okay, so this is called split middle term because you bring down the first, you bring down the last, and you split the middle term into the two numbers that you found. You absolutely could have written that in a different order. So if you wrote -7x -2x, but left your first and your last the same, that is absolutely fine. So this is what we're going to leave it as for today. So then number 2, let's try this. I bring down my first, I bring down my last, and I take my middle term and I split it up into the two numbers that I found, which were -3x and -9x. And I could write those in the opposite order and still get the correct answer. That's fine. Noticing if you combine the middle terms, you get back to what you started, so you're doing it right. Number 3 here, bring down your first, bring down your last, and split the middle term into my two numbers, which were -3 and -3, and each of those have an x. So it's x squared -3x -3x plus 9. So let's try the last two. I would leave 2x squared. 15x would become a 3x and a 12x, coming from our numbers from earlier, and then plus 18. So number 5 here, same idea, bring down the 3x. I have a 2 and an 18. I'm splitting my middle number up into both of those with an x, and then plus 12 at the end. So this process is called split the middle term. And as a reminder, from start to finish, you have ax squared plus bx plus c. You want to find what multiplies to get a times c and adds to get b. So it has to multiply to get a times c, and it has to add to get b. Once you find those numbers, then you're going to split bx into your number pair. And so you'd have ax squared, you'd split your number pair, and then plus c at the end. Okay? So we will go over this more tomorrow, and then we're going to continue to factor more. So if you do have questions, feel free to email me at any point and let me know. Okay? Thank you very much.